Hello students. Today we will start with a very initial chapter of the general physics, that is motion along a straight line. In physics you have to learn this chapter after the measurement part. This is very vital. So we will start with motion along a straight line. So when a particle got a motion or a body in motion, there should be obviously a displacement. A displacement. So this displacement creates a motion. Either it's a particle or body. Anything can be. So let this displacement, we can take a delta x. A delta x means a very smaller part, very smaller part of the total part. Keep it in mind, this delta, always delta conveys the meaning of very small part. So let we can assume the initial position of the body is equal to x1 and final position of the body is equal to x2. So the difference delta x. So students, you can understand what is delta x. Delta x is equal to x2 minus x1. So this is very vital one. Delta always conveys a very small part, where this is in time part also, it's in the velocity part also, or in distance part. When we use delta, it universally conveys a meaning of very small or instantaneous. So we got this displacement. So when displacement got, the particle got obviously a velocity. So we'll go to the velocity part also. So velocity it's a vector in a physical quantity, as we know earlier. This velocity, again we can take the average velocity. So again, as because of we are treating with delta x, so we will take the average velocity part to make here the treatment. So VAVE will be obviously what we have learned previously, this del x, very small part, along with a del t, very small part, instantaneous time part. So as we previously knew, this delta x2 minus x1 is final position minus initial position. Again, similarly, in the same categorically, we can say this t2 minus t1. So this is another formula for the velocity part. So velocity, so If we can understand the velocity, so speed automatically comes, speed also, speed. So what is speed? Again we will take the average part, because of here we are taking the very small part of everything like displacement or time. So if we take average speed, so it will be total distance by that delta t. So average speed obviously will get. So again, if we treat it in the calculus treatment, we have to learn all the calculus treatment, because without calculus in the modern physics or either in the advanced physics, we can't do the numerical parts. So we have to learn this calculus part also. So if v is equal to, we take the limit, we all learn the limit we have in our class 11th. So limit this delta t tends to 0. So this part will delta x, what we have learned, by delta t. So as we implied here, the limit, the function, the limit function will be dx by dt. So this part so far we have. So all other related, displacement, velocity, speed. So when this are coming, automatically another part also comes like this, acceleration. Acceleration. This automatically comes. So what we have learned, acceleration, the rate of change of velocity per unit of time. That is the acceleration part, the rate of change of velocity. So what we can say, the rate of change of acceleration, so it will be acceleration, what we are, as we have taken all the instantaneous small part of the like delta x, delta t, so we have taken this also as an average part, average acceleration part. So average acceleration part will be again v2 minus v1 and t2 minus t1. Just we are writing here the final, here the final velocity, b v2 and initial velocity b v1. Similarly, final time to reach is equal to t2, initial time to start is equal to t1. So automatically what we got from this t1 and t2 and t1 we have implemented here. So this is the acceleration part we have learned. So again with the acceleration part, we applying again what I have told you previously, we have to learn the calculus part, calculus. So applying the calculus, applying the calculus part in the acceleration, we get is equal to what, dv by dt. So the function will be ddt of dx by dt. So this will be d2x by dt2. So this so far we have got, this is the calculation part, to applying the calculus to get this derivations. So this after derivations we have to learn the constant. the constant acceleration. What is the constant acceleration? Constant acceleration. Acceleration, what we have previously learned, the rate of change of velocity is called the acceleration. Now we are learning the constant acceleration. So constant acceleration, keep it in mind, constant acceleration will be what? Similar like that, but a little bit of difference like this: v minus v0 and t minus 0. This v0 is equal to initial part, initial velocity, v is equal to final velocity. Similarly, t is equal to the final time, and t0 means initial starting point. So these are the basic things. Along with this, in this particular chapter, the motion in a straight line, we have to learn few equations. So those equations are very vital. You have to keep in mind, very vital. So if you just keep in mind all this equation, memorize, you can do the 90% of the numericals automatically. This number one, velocity, with the relation with the initial velocity, final velocity, acceleration and time. These are the relation. This one, v square is equal to v0 square final velocity square v0 square initial velocity plus 2a. So difference between the two classes of the particle or the body. So we got this one. Along with this, x minus 0, this the displacement part. So we got v0 t plus half a t square. This is number 3. Number 4, x minus x0 is equal to half v0 plus v t. Number 4. Number 5, x minus x0 vt minus half at square. Number 5. In these cases, constant acceleration will be in the cases of constant acceleration. We know dv is equal to dt. Sorry, adt. dv is equal to adt. So from there we have learned from this, a is equal to dv by dt. We have learned so far by integrating both sides. By, as I told you previously, we have to learn the calculus integrating both sides. What we got, dv adt is equal to a dt. Therefore v is equal to at plus c. This is number 6 what you have learned. Again using the same equation, dx is equal to v dt. Integrating both sides, we will get dx to v dt is equal to v0 plus at dt. Therefore dx is equal to v0 dt plus a t dt. Therefore x is equal to v0 t plus half at square plus c. These are the number 7. So far these are the equations we have to learn very properly and systematically. These are uses because the differences of the displacements of the party or the body we have made like this, or you can use only s as a displacement or the distance covered. So you can use this only x if you think x0 is not feasible, or x like this way. You can only use here as a treatment in a straight line. We actually thought about the vector calculations, so we made it like this way to make it more simpler and easier. So later on when we discuss again, as I previously told you, you have to learn all the calculus part in all the chapters of the physics. So these are the very vital. You have to learn the calculus part as well as the vector analysis part.